So today we are going to talk about some of the question asked in previous CSIR question papers. The correct order of FMF bond angle, where M is metal atom, in NSF3, SiF4 and POF3 is. So four options as given. So first we will take SiF4 and POF3 and NSF3. So here the central metal atom is silicon, here phosphorus, here sulfur. So here if you see how to identify central metal atom, always less electronegative atom will be the central metal atom. So here silicon is least electronegative, and here phosphorus and here sulfur, not nitrogen, is a central metal atom. Here only sulfur is the central metal atom. Now, so as we know that if electronic cloud around the bond increases, so electronic repulsions will increases. Electronic repulsions will increases. If electronic repulsions will increases, bond angle will decreases. This is the concept here. So in case of SiF4, we have all single bonds. Okay, in case of POF3 we have like this. In case of S triple bond N F 2 3. So these are the three structures we have here. In case of SiF4 there is a single bond. So around the single bond the electron density, electron cloud or electron density is very less. So because of that reason here not much repulsions. Whereas when we have a pi electron, there will be a cloud of pi electron cloud also will come into the picture. So in this case we will see a electronic repulsions. So because of that reason this bond angle will decreases, and here we have a triple bond. Because of that we see more electronic repulsions. Because of that the bond angle of this also will decreases. Now if you see the order, so sp3 sp2 sp, this is an order. So the bond angle which is highest in case of SiF4, and after that POF3, and after that NSF3. So if you see the options, the correct option will be this. Next. And the second question is the outer electronic configuration of metal M in a diamagnetic complex with formula is this one, is N-1 D8 configuration. It does not give any precipitate with AgNO3. The correct statement about the complex among the following is. So there are four options are there. It exhibits optical activity, the metal shows sp3 hybridization, can show geometrical isomerization, and it aqueous in its aqueous solution exhibit electric conductance. So it's very simple question to answer. So here he has given metal that is in the diamagnetic state, okay, and N-1 D8, that means he is talking about the nickel metal or any metal which is comes under nickel like platinum, palladium. So nickel, it shows two tetrahedral and square planar, right? In square planar is the diamagnetic and tetrahedral is a paramagnetic, and here it is sp3 hybridization, and here this is a dsp2 hybridization. So from this knowledge we can knock out two statements. This is wrong, and square planar complexes never shows optical activity. This is also wrong, and we'll go for the fourth statement now. In its aqueous solution, it's exhibit electrical conductance. So we'll take some examples here. We have a cobalt NH3 thrice Cl3, and cobalt NH3 thrice H2O Cl2 Cl, cobalt NH3 twice H2O Cl Cl2. If you will add these metal complexes in the AgCl, they forms ions. This it will not form ions, so remaining these two, it forms two ions, it forms three ions. So here they are forming ions. If metal complex needs to show the electrical conductance, means it needs to form ions. This is the funda we need to remember in our mind. So since this is not forming any ions here, it cannot produce more electrical conductance. It can show, but not that. But here it is showing number of ions equals to 3, here number of ions equals 2. So this will conduct more electric conductance compared to this. So from the question, in the question he said that it does not give any precipitate with AgNO3. That means it's not able to form any ions. Okay, so from that knowledge we can knock out this also, and only remaining option equals to C. So here we have a geometrical isomerism. So yes, it shows geometrical isomerism. So this is present in the form of MABCD, right? So here we have a A, B, C, D. So now we'll keep one ligand constant. So we will exchange remaining ligands. This is one isomer, sorry, and we'll keep A is constant here. Now D, B, C, and another one is A, C, B, D. So like this, it shows 3 geometrical isomerism. So the correct answer is this one. So it's very simple question. From the question itself, we can knock out 3 statements we can knock out, because it exhibits optical activity. So never square planar complex will exhibit optical activity, and metal shows sp3 hybridization. Square planar will not show sp3 hybridization in the case of nickel, and it exhibits solution exhibit electric conductance. To form the electric conductance, it has to form the ions. So from the question is clear that it's not forming any ion. That means it's not conduct any electrical conductance. And next question is the NMR of ruthenium N4C8H8 CO3 at 23 gives 1 peak and number of signals at 140. So before attempting this question, we must be knowing about the denticity and hapticity. So here we have this is the one. So when it shows a single peak, when we have a ruthenium here, so of course it's bonded to only 4 electrons, but remaining 2 are not bonded. But if we take at high temperature, that is, he has given 23-degree temperature, so hapticity means all atoms are continuous. All atoms are continuous. And denticity means all atoms are not continuous. All atoms are not continuous. When all atoms are continuous, in that case all atoms are same, you will get a single peak. When all atoms are not continuous, so you will get a different peaks, means different number of signals. So here at 23 degrees centigrade, it shows hapticity. So whereas at minus 140 degree, it shows denticity. So because of denticity, the number of peaks, you can see A, B, B, C, C. So we will get 4 peaks in NMR spectroscopy at minus 140 degrees centigrade. Whereas at 23, we will get only single peak. So here, just like at high temperature, the proton exchange will be very fast. All atoms will be same. But whereas if you take a low temperature, it's not the same. So there will be some differences. We can identify, means all atoms will not be same at low temperature. So according to that, we need to answer this question. So here the answer equals to 4, because 4 different atoms are there in case here, and it shows denticity at low temperatures. We can also say like this also, hapticity at high temperature. Because of hapticity, it shows less number of peaks, we can say singlet, whereas when you have density, it shows a different number of signals. And then we have this question. This is a Siemens-Smith reaction. Siemens-Smith reaction. So Siemens-Smith reaction is very, very important. So it's a very simple reaction that we'll get cyclopropane formation in the product. And now here we have two options. So now we are going to talk about the stereochemistry. So what about the polar group? When polar group is present, that time what about the stereochemistry in the Siemens-Smith reaction? So when you have a polar group which is having a lone pair, okay, like this, so now zinc goes and coordinate to the lone pairs which is present on the polar group. So now as we know that in the mechanism, first Zn CH to Cu, like this is forms Zn CH like this. So since zinc is coordinating to the atom which polar group which is present in the compound, so the cyclopropane formation also takes place same side where the more polar group is present. Since it's present above the plane, here cyclopropane formation also takes place above the plane only, because because zinc is coordinating with this oxygen lone pair. And similarly here we have one oxygen above the plane, one oxygen below the plane. That means here the product is above the plane, and here product is below the plane. So this is about the stereochemistry in the Siemens-Smith reaction. Thank you.